You're all familiar, I'm sure, with Manitoba Hydro.
Yep.
Everyone gets their power. You work for them? Everyone gets their power from them. Why is it called hydro, do you think? Like,
Because it's water.
because it's what?
Hydro dam.
It's made. They make their electricity in Manitoba from hydroelectricity dams, right? Is all of the electricity in Manitoba made from hydroelectricity?
No.
It's not actually. There's actually a coal plant in Brandon, apparently. I just found out about it. And in fact, in Manitoba, we actually talk about hydro as electricity. If you go to say like, Newfoundland or other provinces, they won't understand what hydro is. Hydro is our word for electricity, really, which is kind of weird because it's like water, hydro. But anyways, okay, so after this, you're going to be able to solve for power using P equals VI, another formula. We're going to have to, at some point, make sure we have a list of all our formulas for the test. And you're going to be able to determine the yearly cost of an appliance, and we're not going to read electricity meter. That'll be next. You know how you ever have a parent that yells at you for leaving the lights on?
Yeah, all the time.
All the time. I do it at my house. In fact, my mom and dad, I'll tell you a quick story. My mom and dad were at my place about a month ago, and like my dad went upstairs or something, and like 10 minutes later I go upstairs, and like literally every light upstairs is on. And I'm like, I go downstairs and I said, Dad, are you getting back at me for something or other? Like, are you getting back at me for leaving the lights on when I was a kid? He's like, what are you talking about? I said, you went upstairs, you left every light on. Oh, did I? And like 30 years ago, 40 years ago, guess who he was yelling at for leaving the lights on? Me, exactly. Today you're going to find out just how much it actually costs to run a light all day. You're going to find out. I unfortunately don't have a handout for you today.
Oh, good.
So
That's why we wanted to.
now, I am a big proponent of kids not writing every single word down. Have you been trained to write every single word down?
Yeah.
Likely. Stop that. Especially if you're taking my class in the future. I don't want every word written down. I want you listening, and I want you writing down only what's important. Today, I will tell you exactly what to write down. Okay? Are you flabbergasted?
Yep.
Why? Because the teachers never said you don't have to write every word down? Well, do you think that is something that is worthwhile to write down? Yes. That is something. That's a definition. You should write that one down. Power. Power. Power is simply energy divided by time. And interestingly enough, we talk about power in grade 12 physics. We do a lab that is a lot of fun. You run up the stairs out here, and you determine, you've got like at home, you've got like maybe a 2-horse snowblower or something like that. You've got a snowblower at home, you know how big it is?
Not a 2-horse.
Not a 2-horse?
Like a 10-horse.
10-horse. That's a lot of horses. Okay, so what does that mean, 10 horsepower?
10 horsepower?
What does that mean?
Power. It has the power.
It basically has the power of 10 horses. Okay? When you run up the stairs in my lab, Andrew, you should be listening to me. When you run up the stairs in my grade 12 physics lab, you will determine your own horsepower. Are you as powerful as a horse?
Yes.
Okay. So power is defined as energy divided by time. In other words, power equals E divided by T. E divided by T. Yes, Blake, write this all down. Everything that's up there so far. E divided by T. E is energy, T is time. No, in fact, sometimes I slip into this one here, although big T has another meaning in physics, and that's why. So I tend to write small t for time. Good question. You might remember from about, 3 or 4 weeks ago, that E is equal to Q times V.
Oh, damn. I'll get it.
Do you remember E being equal to QV?
Yeah.
If you don't, that's fine. So what I'm going to do is I'm going to replace the E right here with with Q and V. You can draw that arrow in there if you want. Okay?
Well, fine.
I'm going to replace the E with the Q and the V. And then what am I going to get? QV over T. Well done. Okay? What we're doing here, you guys, this is called formula derivation. We are deriving, we are creating a new formula. We do some of this in grade 12 physics. In university, that's all professors seem to do, it seems, right? So you're doing a little bit of algebra here. It's a good sort of pre-run for you. I'm not expecting you to be able to do this. I'm just showing you what the new formula is going to be. Okay? You're not going to have to duplicate this. But it's still a good idea to write down just to get the experience. Okay, so I'm going to replace E in the formula with Q and V. And now I got P is equal to V over T. Now, there's one other thing that you might notice. Do you remember that current is defined as Q over T?
Yeah.
That one you might remember more. Current I is equal to Q divided by T. Do I have a Q divided by T?
Yeah.
I do. I have Q divided by T right there. So I can replace Q divided by T with I. I can replace Q divided by T with the letter I.
So P was
Because the formula has a box around it, that means I'm done. Okay, we have derived, we've come up with the power formula. P is equal to IV. P stands for power, I stands for current, V stands for Dawson. I'm waiting for the flash to tell me. V stands for volt. Okay, what do we measure voltage in? Dawson, I'll give you another chance. Don't yell. V. What do we measure voltage in? Volts. What do we measure current in, Andrew? Amps or amps, not something, amps. What do you think you measure power in? Oops. Is that what you said? Oh, no, that's resistance. Ohms.
Oh, yeah.
Ohms. Yeah. Actually, we measure power in watts, named after this guy, James Watt.
Write that down.
You don't need to know that. That's just a trivia thing if you're playing Trivia Pursuit. You do need to know, though, that actually power is measured in watts. Oh, yeah, you need to draw a picture of this guy, too.
Oh, yeah? Yeah. I'll paint them.
Okay? James Watt was not, a lot of trivia games will say that James Watt was the inventor of the steam engine. Not true. James Watt was the guy that took the steam engine and figured out what it could be used for. The developer of the steam engine. I think it was, I don't know. I'll have to look that up. Let's do that right now.
No, go back. Carry on central.
Steam engine inventor.
Yeah, I've been on that one. In grade 3 or 4?
Yep.
Yeah.
Thomas O'Leary.
Were you helping me? Oh, I couldn't stand here. Oh, you were there, for sure.
The Spanish inventor Jerónimo de Añas Beaumont patented it in 1606.
What kind of steam engine? Like a steam engine car or steam
No,
engine?
just a steam engine, right? 1781, James Watt patented a steam engine that produced continuous rotative motion. Watt's 10 horsepower engines enabled a wide range of manufacturing. So he was the guy that really first sort of did something with them. Everyone else was sort of like demos kind of
What
thing.
about train 351?
Yeah, they would have been based on him, right? Okay, so power is measured in watts. Have you ever heard of watts before?
Yeah.
Where?
When you measure something.
Light bulbs?
Yeah.
Generator? Where else? Phones?
Generator.
Yeah, generators. When I was a kid and like everyone had a stereo, you wanted to have big speakers. I had like
subwoofers.
Yeah.
Those have.
for an amp, 200 watt amp, right?
Yeah.
I got a bass guitar amp at home that's like a 40 watt amp. It's not very big. A little practice one that's like 10 watts. Did I say amps? I did, right?
Yeah.
An amp has a power of watts. You got it, amplifier. Right? Watts. Okay. Anyways. Okay. So, do you want to do these sample problems with me?
Yeah.
Probably. Should you write them down so you know what? Yeah, likely, right? How about I give you a couple minutes, write them down, leave a space, right? And then we're going to do the answers right away.
Oh,
Why don't we do one at a time?
You can do that if you want. So, have you got an electric can opener at home?
yeah.
Or do you have like a crank
Yes,
kind?
I know.
You have both?
You have to
Okay.
keep on buying it, McGraw should break some.
The crank kind?
No, like the power kind.
Maybe you should buy the crank kind. She still breaks that too. Maybe she needs a lesson. She like pounding it to open the can or something?
Yeah. Huh? She gets mad and throws it and.
She always does it together.
Okay, yeah, she's got a can
She broke
opener.
my tablet one time.
All right. Remember, when you're solving problems like this, always, you guys, please, always write the formula. The other thing, too, is you should write what you're given, right?
And all in one.
So V is equal to 120 volts. The current I is 2.2. Okay, so write the formula. P equals IV. 2.2 times 120 volts. So I'm going to need a calculator. $664? Okay. 264 watts. Now, how long do you run a can opener for? Well, in Andrew's house, not very long, apparently, because they break.
What?
But the average person at home, like if you're opening a can, how long does it take? Maybe 10, 15 seconds, right?
A couple seconds.
Yeah. Not very long, right? So it doesn't have to run for very long. Let's talk about a TV. A TV in your chouse. I don't know what a chouse is.
Oh, I got it.
Did you write chouse?
Yeah, I got it.
A TV in your house is plugged in so it receives 120 volts. Every outlet in your home supplies 120 volts. If the current use is only 1.1 amps, how much power is required? Well, is it going to be more or less than 264?
Oh, less.
Why less?
More.
Because 1.1 is the...
Is considerably less than 2.2.
Yeah.
Do TVs take more power than can openers, you think? Like, do can openers need more power to open that can?
Yeah.
Yeah, likely. There's some actual cutting, like it has to, right? There's some power needed. Whereas, like, TV, how much, it's just light, really, right? Okay, so once again, V equals 120. The current is 1.1. P equals IV. 1.1 times 120. 132 watts. Okay, that's pretty good. I think you guys can all do those, right? That's pretty easy. Yeah. That's going to be an easy mark on the test. Make sure you get it.
Oh, I realized that...
Cheat sheet?
Calculator.
Yeah. We're going to make one the day before the test.
Calculator.
Yeah.
Make a calculator.
No, a cheat sheet, not a calculator. Yeah. Thank you. Even more awesome than before. New and improved, Mr. Bennett. Even more awesome than before. Easy stuff, right? Okay. I hate to tell you this, but it's going to get a little bit harder. That's the easy part. Okay. Now, Manitoba Hydro doesn't just charge you like they don't. Like when you open the can at home, is there like a slot to stick a nickel in to pay for the power? No. It doesn't work that way, right? Doesn't work that way. Okay. So yes, you do have to pay for how much energy you use. Do you need to write that down?
No.
Is there anyone here that doesn't know you have to pay for the electricity? I don't think so. Don't write that down. Manitoba Hydro measures this in what's called a kilowatt hour. Okay, they measure them in kilowatt hours because you're paying for energy. Energy is actually measured in joules, as you might remember. You should probably write that one down. And the current cost, I looked it up online, the current cost is 7.381 cents per kilowatt hour. Guys, you need to listen, okay? 7.381 cents per kilowatt hour. I need to do some explaining here. Mr. Bennett, you got some explaining to do.
Kilowatt hour.
Kilowatt, now it's not kilowatts per hour, it's kilowatt hours. How many kilowatt hours are you using?
What is that?
I'm going to explain that right away. It's very confusing. Okay? Cost is equal to the power multiplied by the time multiplied by the unit cost. And that unit cost, Blake, please don't. Come on back, you're missing stuff. And don't touch people on the way. So the cost is the power times the time multiplied by unit. Now the unit cost is always going to be, now does this number ever change? Does the cost of electricity ever go up or down?
Yeah.
Yeah.
Mostly it goes up, but I don't think it ever goes down, right? But for now, for the rest of the week, 2 weeks, we're going to use that number, okay? It's not going to go up, change that number. Time, I think you all know, hours, and power is what we just calculated. We just did that. P equals I times V, right? So it's the power that you used, your can opener, multiplied by your time, multiplied by 7.381 cents per kilowatt hour. Okay, when that kilowatt comes into the power here, what does the word kilo mean? The prefix kilo.
Kilogram.
1,000.
1,000. Kilo means 1,000. Do I have that coming up on the next slide, I wonder? Kilo means 1,000. Do I have it up on the next slide? Sort of. Kilo means 1,000. So a kilo, 1 kilowatt would be 1,000 watts. That's a big stereo. Did you know, Andrew, that you can actually, your 10 horsepower snowblower, you can convert to watts? The metric way of measuring horsepower is in watts. There's about 760 watts per horsepower, I think. So 1 horse or 10 horse would be like almost 8,000 watts of power. A kilowatt is 1,000 watts. So let's just go back to here. Can we change these to kilowatts? Just for practice?
No.
Let's change these to kilowatts just for practice. So 264 watts in kilowatts. Divide by 1,000. You guys know about the moving the decimal place thing? So 0.264 kilowatts. This one would be 0.132 kilowatts. Right? Okay, always move the decimal place 3 places. Okay. So, did you not get that down? Sorry. You know what? When I made this slide up, I said, you know what? I'll bet you $100. I said it to myself, so I knew I would win. That someone would say, oh, that's almost $2. But it's cents. To run the can opener for an hour would cost 1.9 cents.
So,
How about the television? Well, remember the television was like, let's go back here. This was 264. The TV was only 0.132 kilowatts for an hour.
So what you're saying is we can run
It'd be like about a cent an hour.
for television?
About a cent an hour.
I'll go for internet. And my mother knows that.
Yeah, what about the cheapest guy? It's only cost you a cent, mother.
Am I going to get in trouble with a whole bunch of parents now?
Yep, probably. Yeah, I miss it.
What about that 100-watt light bulb that you left on? You know, you went out and maybe you went to Granny's for the night,
How long is all night?
and you leave your 100-watt light bulb on in your room. How much does it cost?
It's gonna cost like
Do you want to? It's up to you whether you write that down.
$1.
So how long is that time? 8 p.m.
100 watts. First of all, we got to convert to kilowatts. So 0.1. Let's say, I'm not saying you went to bed. I'm just saying you turned the light on at 8, and then you went to Granny's house and you spent the night. You came back at 8 o'clock the next morning, right? So you've run that bulb for 12 hours.
It's gonna cost you 10 cents.
Power times time times unit cost. Can you do it on your own? Try it right now. Try it right now. See if you can get the answer. I've given you everything you need. You just need to do it.
Wrong.
Power times time times unit cost. I've given everything you need. Is this what you did?
Yeah.
Power is 0.1 kilowatts. Time 12 hours. Cost 7.381 cents. Multiply them all together. What do you get? It's about 9 cents.
I just 10. That's for 12 hours.
Yeah, TVs generally are LEDs, right? Like they're, and I just sort of, to be honest, I just made those up. This, about a 100-watt light bulb is, what'd you say?
LCD.
Oh, like the TVs you mean? I don't know. But you're going to start finding some of these things out. So yeah, if you run that light bulb for a whole hour, it's about 9 cents. Now you might say, okay, yeah, well, big deal, 9 cents. I can find that in my, in my loose change in the couch cushions counting, right? But if you do it every night, it does add up, right? Like that'd be for a week, that'd be like 70 cents. A month, that'd be like $2.80. That starts, that's one light. You do that 4 or 5 lights, it starts adding up pretty quick. So yeah, turn your lights on. Yes, sir. Really good question. Now they say that the 100-watt light bulb is sort of the standard. The curly ones give off the same amount of light, but they are rated at 13 watts. How would you convert 13 watts to kilowatts? That would be 0.013.
Apparently the curly ones aren't good for your health.
Well, not if you eat them. Yeah, they got mercury in them. So it would be like considerably less, wouldn't it, right?
You know those long tube ones?
Yeah, like these ones?
Those like the ones in the shop?
Yeah, they are.
No, they're not. Big, really long.
Oh, okay. Well, these are just shorter long ones, that's all.
Anyway, they have mercury in them, and if you break them, you'll die.
Well. Okay, you're going to have an opportunity to investigate that in a little bit. Okay, have you ever seen one of these?
Yeah.
Is it on your washing machine?
Yeah.
You're in luck. Because you're going to the assignment's going to be easier for you. If you go into the appliance store, they all have these on them, right? Okay, so it's a Canadian way, it's called the Energite, and it tells you the estimated amount of energy to be used in a year. And let me just fix that word there. Okay? To calculate the cost to use this washer, or whatever this is, multiply by the number by the cost of electricity. Because this is already in what? Kilowatt hours. They've already told you what it is, kilowatt hours. It's the estimated kilowatt hours per year. Okay? And it's a bit of an average. Some people will only use 481 kilowatt hours. Some people will use 683, so it's sort of the average. Okay? If you use this washer or whatever it is, you can expect to use 554 kilowatt hours in a year.
Mine's 1,000. In
a year. Okay? So you take 554 kilowatt hours times by 7.381, and you get 4,089, not dollars, cents, which is about $40. So that washing machine uses about $40 per year. Per year for electricity. Okay? That's without the water. That's just the electricity cost. Just the electricity cost. Okay, does that make sense? No.
What if you live in a country and you have a well?
The water's free then, right? You still got to pay for electricity though, right?
You just pay for electricity.
Yes. Now, what was the difference between these ones and this one? Here, I just took this number multiplied by the cost. Ladies, please listen. Just take the cost multiplied by the this time amount multiplied by the cost. Here, I had to multiply by the hours. How come? Because these were just powers. These are already in kilowatt hours. They've already done that for you. Okay? Okay. According to the Canadian government website, I looked this up. These are the average energy ratings for washing machines for the years 1990 and 2010. So they went into department stores, appliance stores, and they looked at washing machines in 1990, and like 1997, and then down the road kind of thing. And this is what they found. Okay? In 1990, the average one used 1,218 kilowatt hours in a year.
Oh.
In 2010, because the scientists have figured out ways of making them more efficient, look at that. How much more efficient they are.
What about present?
Well, it would probably be, I would think that they've probably leveled off that way. They're not going to get much more efficient. Look at the jump just from 2001 to 2010. How long have you had your washing machine in your house? Who knows, right? I know, I've had it for 12 years.
We have one.
So mine was built in about 2000, yeah, mine's in here somewhere. If I buy a new one, I save money.
I do one, and then
How much money will I save?
we just got one there.
Yeah? Well, let's just see here. Oh, I didn't want to do that.
We have one of those.
What would be the total cost to a homeowner if they bought a new washer in 1990 and ran it for 20 years?
Oh God.
How would you figure that out? If you bought this new washer,
You go one.
And ran it.
18 times 20.
ran it for 20 years. This, remember, is kilowatt hours, but it's per year.
Can I use my phone?
As a calculator? Sure, go ahead. So you'd take 1218 times 7.381, and you'd get 8990, but that would be cents, which is about $89 a year, or over 20 years it would cost you $1,700 to wash your clothes, just the electricity.
Is the water?
Yes, sir.
But if they ran it 20 years, the price changed.
That's true. The price of electricity likely was cheaper back then. You're absolutely right. The cost would likely be lower. You're absolutely right. We would have to find out what the cost was in 1990 and maybe take an average somehow, right, Steve? Yeah, or do it per year. You're absolutely right.
So you're spending no money with that water.
Okay, so what if they bought a new one in 2010 and ran it for 20 years? How much money would you save by buying a new one?
If you're after 20 years.
How would we figure this out?
Then price would go up.
We'd take 319 times 7.381 would be 89. Oh, that's not right. That's wrong. I didn't change it. I cut and paste. So what should this be? This should be 4709.1. Tell you if it's not. We're almost done, you guys. It would be a total cost of $470. Look at how much cheaper it is for 20 years. I'd have to multiply this by 20. Okay? So sometimes it might be worth to go spend $800 on a new washing machine. How come?
It's cheaper.
Just because you're going to save that money, right?
Just think about that then.
Yeah.
How much is it for 2009?
Okay.
You can do it. It's not hard. It's not hard at all. Okay. I think, yes, I'm going to stop talking. This is your last portfolio assignment. Okay? Right here. Some can be done in the room, some has to be done at home. Listen carefully. For all of the questions, use that cost that I've given you. Okay? In Mr. Bennett's class, there is a fan. Actually, you're all fans of me, aren't you? New and improved, super awesome. There is a fan, there is a pencil sharpener, and there is a wireless speaker. You need to determine the power required to run that device and determine, wireless from the microphone, determine the cost to run it for 8 hours at a time. How are you going to figure that out? I'm going to leave that to you. Okay? Then I want you to, this is exactly what Ethan's question was, determine the yearly cost difference between using a 13-watt fluorescent bulb and a 100-watt light bulb in your home. Assume they're on for 4 hours per day for an entire year. Ladies, I need you to listen, okay, so you know what's going on. On the back side is at home. Okay, the backside is at home. In your home, determine the cost to run at least 3 appliances. Here are some examples. Fridge, stove, washer, dryer, freezer, toaster oven, toaster, coffee maker, microwave, TV, stereo, computer.
Hot tub would be a big one.
Hot tub would be another good one. If you're lucky, there may be an Energize sticker on your appliance, or you may have it with the instruction manual. Otherwise, make assumptions like how many hours per day they are in use to calculate the kilowatt per hour, and there's an example. Okay? Assuming your microwave has a rating of 100 watts, I assume it's used a maximum of 30 minutes per day for 365 days. That's a guess. 100 watts divided by 1,000 is 0.1 kilowatts. 30 minutes is half an hour. Your microwave costs you about $1.43 per year to run. Okay? So you can do the front side in class today. The back side, you're going to have to do at home. If you need to bring in some data and need some help, I'll be happy to assist with that. This goes in your portfolio, which is I'm going to hand to you very soon. You have 18 minutes.
Not yet.
Look at the